Hello everyone, welcome back to my YouTube channel, and in today's video we're going to solve practice set 2.3. This practice set 2.3 has questions in which we have to solve the quadratic equations but by completing square method. So in the previous videos we have learned how to do it by the factorization method, right? But now we are going to study a new method which is called as completing the square method. So why do we use this method, children? See, the quadratic equations there are certain quadratic equations which cannot be solved by factorization method because we cannot find two factors whose sum and multiplication are uh, uh, are satisfying the given conditions. Okay, so that's why completing square method is used for solving such quadratic equations. So there are various steps which are to be followed when we are solving such kind of equations. Now the first thing that you have to always see is that you have to check whether the given equation, like you can see in front of you, that x squared plus x minus 20 is this equation in the standard form. Okay, so that is a first step. Standard form means it should be in the form of ax squared plus bx plus c. So as we can see, this equation is correct. So we should first check whether the equation is in the form of ax squared plus bx plus c is equal to 0. That is the first step. Okay, then what we have to do, we have to consider the first two terms on the left hand side. Now what are the first two terms on the left hand side here? Like for example, if you see here, x square and x are the first two terms. Okay, so we have to find out the first two terms on the LHS, and then we have to find out the third suitable square term to make the polynomial a perfect square. What are we doing? We are first writing x square plus x, and then after that we are putting such a number which will be a square number, and then we are going to solve it further. Okay, so for that, what we are going to do, we are going to compare this equation. We are going to compare this equation with something. What is that? That is something that, identities, and that identities we had three formula, if you remember. Okay, the first one was a plus b the whole square, which was a square plus 2ab plus b square. This was the first one. Then we had the next one, a minus b the whole square. So that in that case we have a square minus 2ab plus b square. If we have this question like this, x square plus x, so we are going to consider x and y terms here. Instead of a and b, we'll consider the formula as x plus y the whole square is equal to x square plus 2xy plus b square. So the same formula I'll consider as x plus y the whole square. The same formula I'm considering as x square plus 2xy plus y square. Okay, so with this we are going to compare it, this given equation. We also had one more equation, a plus b, a minus b, which was equal to a square minus b square. Okay, so these are the three formulas which we have already learned in the lower classes. So we're just going to compare this given equation with this. Okay, and what we are going to do, we are first going to consider the first two terms, and we are going to compare it with this x square plus 2xy. Okay, so that will be our first step, comparing x square plus x with x square plus 2xy. You can see on the screen, and then we are going to find out a y square, which we are going to find out the y square, and then we are going to proceed further. Okay, so this we are going to find out. So now what we will do as of now, so we are going to erase the entire thing that is there on the screen, and we are going to proceed further. Okay, so now when we are going proceeding further, we are going to compare this. Now x square plus x is equal to x square plus 2xy. Okay, so when we do that, what do we get? X is equal to 2x. So now how do I get this, children? See, for that what have I done here, pay attention. So this x square will be equal to x square, not a problem. Okay, so what are we comparing? X is equal to 2x. So that's what we have written here. X square is equal to x is equal to 2x. Then nothing. We have to find out y. So we'll shift the everything else on the other side. So 2x will go on the other side. So 2x has been multiplied with y. So when it will go on the other side, children, it will become 1 is equal to 2y. Why am I writing this, children? Because when this x will go on the other side, it will get cancelled. Okay, this x and this x will be cancelled because x will go in the denominator, and you'll be left only with 1 is equal to 2xy. Okay, then we shall proceed further and find out what is y. So as we can see, y is equal to 1 upon 2 because we are shifting 2 on the other side. But when we are shifting 2 on the other side, children, what do we get? Only y. And what are we supposed to find out? As I have circled here, we are supposed to find out what is y square. So I will find out what is y square here. So y square, I am just going to square it. So it will become 1 square upon 2 square. So y is equal to half. So y square will be 1 upon 4. Okay. I'm so sorry. This will be 1 upon 4. This is 1 upon 4. Okay. Now after this, we are going to solve this further. Now y square we have got. So now we are going to change this equation into some other form. Just have a look. See. Now we will write down this equation, x square plus 2x. Now what we will do, we'll write down x square plus x minus 20, this equation, and then we'll separate this x square plus x. Okay, we'll write down x square plus x, and in between we are going to write down this plus 1 upon 4 minus 1 upon 4, and then this 20 we are going to write down at the end. What did I do? I wrote the first two terms here, then after that we write down y square. So this 1 upon 4 plus 1 upon 4 minus 1 upon 4 we write down. This we write down because it does not change the value of the equation. And then finally this 20 was remaining minus 20, which we write down here. Okay, so we first two terms we separate from the third term. Okay, after that what we have? So then we're just going to, let me clear this so that you understand it in a better form. Now as you can see here, we have got two groups, this one and this two. We're going to make two groups, and this will be in this form. If you see, this will be x square, this is x, and this is y square. Okay, so this is given to us and we are going to convert this in x plus y the whole square form. Okay, so वो हम करेंगे. So let us have a look now. This is the expanded form which is given to us. We are going to reduce this further. So let us do that. Okay, so we'll form two groups, if you can see here. So as we can see here, we have formed two groups. So first one, we have written first three terms, and then this we have to be very careful. For this we put the bracket, but when we are putting bracket here, no, for this we cannot put it directly, children, because if you put it directly for minus 1 upon 4, it's correct, but this what will happen if you put directly minus into minus will become plus, right? So what you are supposed to do is, you are supposed to be very careful when you put the bracket. When you will put a bracket, when you separate them, what will happen? This the sign of this will be changing. It will become plus. Why? Because when you open the bracket, plus into minus will give you minus. Is that clear? Yes. Now we shall proceed further, and we are going to just solve now. Almost half of the part of the sum is covered. Now we are going to solve this. How are we going to solve this? So as you can see on the screen, this is the expanded form of the equation, x square plus x plus 1 upon 4. So we are going to we are going to construct it. What we are going to do, we are going to see whose square is x plus 1 upon x square plus 1 upon 4. So x, so this we have also done earlier. We look for the first and the third term. Okay, and we see whose squares are these. So x square is a square of x, and 1 upon 4 is a square of 1 upon 2. So this becomes x plus 1. See, this is the expansion of this. अगर ये x plus 1 upon 2 को हम फॉर्मूला से सेपरेट करेंगे, x square plus 2 into x into half, तो हमें ये इक्वेशन मिलेगा ऊपर वाला. Okay, we'll get this when we are going to square this. So like this we are going to do. So here expanded form is given, हमने उसको convert किया. Similarly, we are going to solve the next part. So if you solve the next part here, this bracket is going to be bigger like this. Okay, this is going to be like this. So 4 into 20 is 80. 80 plus 1 is 81. Like that you can do, or you can cross multiply and do. Okay, so 81 upon 4, which is equal to 0. So again 81 upon 4 is also a square of something. You can see 81 is a square of 9 and 4 is a square of 2, right? So we are going to write down that. So x plus 1 upon 2 the whole square minus 9 upon 2 the whole square. So we are just going to write down this 9 upon 2 the whole square. Then you can see, children, this is nothing but a square minus b square. See this. So this a is entirely x1 upon 2 and b is entirely 9 upon 2. So इसका expansion क्या है? a plus b, a minus b, correct? So a plus b means x plus 1 upon 2 plus 9 upon 2. This is your entire a. This is your entire b. So a plus b, a minus b. Okay. This is the expansion here. And then we are just going to solve this further to get our answer. Okay, so this 1 upon 2 and 9 upon 2. So let us solve this. So x plus, what will happen to 1? Since the denominator is same, we can add the numerators. So 1 plus 9 is going to be 10 upon 2, and this will be x is equal to, now this 1 minus 9 will be minus 8, because 9 minus 1 is 8, and the sign of a bigger number, which is 8 upon 2, is equal to 0. So we can solve this further. 10 upon 2 is going to be 5 and 8 upon 2 is going to be 4. Now we are going to separate this. So we will write down x plus 5 is equal to 0 or x minus 4 is equal to 0. And then we'll shift this plus 5 on the other side. So x is equal to minus 5 and this minus 4 will go here. So x is equal to 4. So the answers are x minus 4, 5, 4 are the roots of the given equation. So this is your first sum. Okay. Now let us proceed towards the second sum. X square plus 2x plus minus 5 is equal to 0. So as always, we are going to compare this with, okay, first we are going to check whether it is in standard form. So yes, it is in standard form, ax square plus bx plus c form. So there is no problem here. So we are just going to proceed further towards the next step, and we are going to see whether we are going to compare this with x square plus 2xy. Yes, remember the expansion, x plus y the whole square. Yes, so the expansion will be x square plus 2xy plus y square. So we are going to compare this with 2xy and we are going to find out y square, right? So we are going to compare x square plus 2x with x square plus 2xy. So automatically x square is equal, not a problem. So 2x will be equal to 2xy. So 2xy is equal to 2x, as you can see on your screen, and then you're going to solve this further. So 2x, if I bring it here, I want to find out what is y, right? So for that, what am I supposed to do? What I do is this 2x, if I bring it here, it will go here in the denominator. Yes, and y will remain alone. So and this will get cancelled. So you will be having y is equal to 2x. Y is equal to 1. Okay. Now let us proceed further. We are going to find out what is y square. So because you are supposed to find out what is y square as per the equation you can see here, right? So we'll find out y square, which is equal to 1. अब क्या करेंगे हम क्या करने वाले हैं? We are going to write down this x square plus 2x, and then उसके बाजू में हम लिखेंगे plus 1 and minus 1. So first we'll write down the original equation, what is given, and then we're going to separate this. First two terms of the left hand side we are going to write first, and then उसके बीच में हम लिखेंगे ये y square जो हमें मिला है, plus 1 minus 1. So this will be plus 1 minus 1, and this minus 5 we write down at the end. Then we make the groups, पहले तीन terms का and last के दो terms का. So when we are making group, we'll be having x square plus x plus 1 minus, this is a minus sign outside, so अंदर का जो second term का sign है, that will change and it will become 1 plus 5. Okay, because if you see minus into plus will be minus. So now we will see x square plus x plus 1 किसका square है? So x square is a square of x and 1. We are not bothered with the middle term, उसका हमें कोई लेना देना नहीं. We are just going to see first and the third term. So first term is the square of x and third term is a square of 1. So this will be x plus 1 the whole square minus 1 plus 5 is equal to 6. But now we are going to convert this in the form of a square minus b square. So a is x plus 1 the whole square, b हमारा square नहीं है. 6 is not a square of any number. So such numbers, if we want to consider the square, this will be the square of root 6. या अगर यहाँ पे 10 होता तो ये स्क्वायर होता √10 का. So here I consider this as it is a root square of √6. फिर we got this as a plus b, the a square minus b square from, so it will be a plus b, a minus b, right? So how will this be? So this will be your entire a, this will be your entire b. So हमारे formula के हिसाब से it will be a, which is x plus 1, a plus b, a minus b is equal to 0. Okay, and then बीच में कोई साइन नहीं रहता because this is a plus b one bracket, a minus b other bracket. Then what are we going to do further? We are going to separate this two brackets. We are going to consider the two brackets separately. So we'll say x plus 1 plus √6 is equal to 0, or x plus 1 minus √6 is equal to 0. Then we're supposed to find out what is x. So we'll keep x alone and we'll shift this on the other side. So plus 1, when it goes on the other side, it will become minus 1, and plus √6 also becomes minus √6. Okay, similarly here, as you can see, plus 1 if it goes here, it will become minus 1, and minus √6 when it goes on the other side, it becomes plus √6. So these are the roots of the quadratic equation. Minus 1 minus √6 and minus 1 plus √6 are the roots of the given quadratic equation. Okay, of the given quadratic equation it will be. Quadratic. Now let us move towards the third question. So m square minus 5m is equal to minus 3. So as always, we are going to check whether this first step is proper or not. So whether this equation is in the form of ax square plus bx plus. So we are going to check this. Okay, x square plus bx plus c, is it in that form? So if you see here, it's not in a correct form. It's not in a standard form. So we'll first convert this equation to a proper form. So to do that, what we'll have to do? We'll have to bring minus 3 on the other side, and then minus 3 is going to become plus 3. So this will be m square minus 5m plus 3. After this, what we are going to do? We are going to compare this. So now how are we going to compare this with? So here m is given. So our equation will be in the form of m plus n the whole square is equal to m square plus 2mn plus n square. So this is how we are going to write down the equation. We are going to compare this with, and we are going to compare our equation with m square plus 2mn. Okay, we are going to compare this. But since there is a minus sign here, this our equation will not be m plus n the whole square, and that it will be f minus n. Okay, so here we will take m minus n the whole square because our equation is having minus in it. Okay, so m minus n square. So we are going to compare this m square minus 5m with m square minus 2mn. You can see. Okay, so this m and m is equal, not a problem. So what remains? Minus 5m will be equal to minus 2mn. So minus 5m is equal to minus 2mn. Now after this, what are we going to do? So we are going to solve this further. When we are going to solve this, we are going to find out what is the value of n, because we have to find out what is n squared, right? So we'll shift the minus 2m on the other side. So this will become minus 2m, and then minus and minus is going to get cancelled. Even m and m will get cancelled. So it will, what will remain is only n is equal to 5 upon 2. But we are going to find out the square of n, right? So we'll find out what is n square. So when we find out n square, what will we get? So n square is equal to 25 upon 4. The square of 5 is 25 and the square of 2 is 4. Then we are going to proceed further and we are going to write down the given equation. So what is the given equation? So the given equation is m square minus 5m plus 3. Now we are going to separate the first two terms out of it. So and then we are going to insert, we'll separate these two terms and we are going to insert this 5 upon 4 in between. So this will be m square minus 5m is equal plus 25 upon 4 minus 25 upon 4 plus 3 is equal to 0. Then we'll make parts of it, we'll put brackets. So this will be the first three terms which we'll put in one bracket, and minus, there is a minus sign here, so this will become 25 upon 4 minus 3. So this is how we'll get, and then we will check whether m square plus m square and this It's an expansion of whom. So we'll check m square is a square of whom? It is the square of m. And 25 upon 4 is a square of whom? It's the square of 5, and 4 is a square of 2. So, and there is a minus sign here. So this is a formula of m minus 5 upon 2 the whole square. I repeat, it will be the square of m minus 5 upon 2 the whole square. Okay, and this 4 3s are 12, so 24 minus 12 when we'll do, we'll get 13, and this 4 we write down here. But 13 is not a square of any number, 4 is, right? So what we'll do for 13, we'll write down root 13, and for 4 we'll write down 2, right? So we'll write down this like this. It's a square of 2. You can put this in the big bracket properly. So it is like this. So root 13 ka square is 13, and 2 ka square is 4. So this is a minus b, and a square minus b square. So we'll write down this in the form a square minus a plus b, a minus b. Okay, so as you can see, I've written a minus b and a plus b form here. If you can see, this is m, this is your a plus b, this is a minus b. Okay, and then we just separate the brackets and we write down zeros for them. Then we are going to shift minus 5 upon 2 on the other side, and we'll get it plus 5 upon 2. See, we are shifting this entire thing on the other side to get the value of m. So minus 5 upon 2, when it goes here, it becomes plus 5 upon 2. Plus root 13 upon 2 goes here, it becomes minus root 13 upon 2. And similarly, a minus 5 upon 2, when it goes on the other side, it becomes 5 upon 2, and this minus root 13, when it will go on the other side, it will become plus root 13 upon 2. So these are our final answers. So since the denominator is same, we have written the numerators together. So 5 plus root 13 and 5 minus root 13 are the roots of the given quadratic equation. Thank you.